All right, next in our unit on rational functions, we're going to learn how to simplify complex fractions. And so a complex fraction is a fraction that is made up of multiple fractions. So we have 4a squared minus a minus 5 divided by 20 over a over 5 minus 1 over 4. So overall, we're dealing with a fraction, but then there's a fraction and a fraction and a fraction all within that single fraction. So we have 3 fractions within one, and that's what makes it a complex fraction or like a complicated fraction. So what we're going to do is we're going to simplify this until our final answer is just one fraction or even better, just an expression if it simplifies that far. So what we're going to do is we're going to do this problem kind of like the long way, and then I'm going to show you guys kind of like a shortcut for it. So if we were doing this problem, we can see that on the bottom there's a subtraction problem, and so we're going to start there. We're going to say, well, to subtract 2 fractions, we need a common denominator. And then what we have is we have a fraction divided by a fraction, and when we do that, we do keep it, change it, flip it. So first we're going to get a common denominator between these two, and then we'll do the keep it, change it, flip it to do this problem. So to save ourselves a headache later, we're going to get a common denominator between all 3 of these denominators. So between 20 and 5 and 4, the common denominator would be 20. So on the top, we already have the common denominator of 20. On the bottom, for the denominator of 5, we need to multiply by 4. For the denominator of 4, we need to multiply by 5. Right, so at this point, the fraction that is in the numerator is going to go ahead and stay the same. So we have 4a squared minus a minus 5 over 20. And then in the denominator, we have 4a over 20 minus 5 over 20. So now we can go ahead and instead of writing it as 3 fractions, we can just write it as 2. 4a minus 5 over 20 divided by 4a minus 5 over 20. And so now that we have division happening, a fraction divided by a fraction, we can do keep it, change it, flip it. Keep it, change it, flip it. So keep the first fraction the same, change it to a multiplication problem, and flip the second fraction. And now that we've done that, we just have a multiplication problem. And so now we can go through the process of take every part of the fraction and factor it, and then whatever you have, go ahead and cancel your factors, and we'll be done. So with this problem, we're going to go ahead and do the slide divide method for factoring. So 4 times negative 5 is negative 20. So we're looking for what multiplies to negative 20 but adds to negative 1. And that's negative 5 and positive 4. So we have a minus 5, a plus 4. The number that we slid was a 4. So we have 4a minus 5 and a plus 1. Okay, so for the first fraction, I have 4a minus 5, a plus 1, over 20. For the second fraction, I have 20 over 4a minus 5. And now I can go ahead and cancel everything that divides to equal 1. So 20 divided by 20 is 1. 4a minus 5 divided by 4a minus 5 is 1. And the only thing that is left over is my a plus 1. Right, so that is the long method for these problems. That's the long way of doing the problems. I'm going to go ahead and show you guys kind of a shortcut that we're going to use for this. And the method that we're going to use is we're going to multiply by 1. We're going to multiply by a well-chosen 1 for the entire complex fraction, and we're going to multiply the entire complex fraction by the least common denominator for all three of the denominators. So we're still going to be using this part where we find the 20, but we're not going to do all this process, okay? So we're going to go back to the same example and we're going to use this other method. So we're going to say same example, but using the other method, and then we're going to use that shorter method to do the remaining examples. So I've got 4a squared minus a minus 5 over 20 divided by a over 5 minus 1 over 4. And I'm still saying that my least common denominator, it's still 20. For all three pieces, it's still 20, okay? So now, instead of saying I'm going to get a common denominator between all three pieces, I'm going to say that I'm multiplying this entire fraction by 1. And the 1 that I'm multiplying it by is 20 over 20. 20 over 20, okay? So I'm going to take the 20, I'm going to multiply it by the top. I'm going to take the 20, I'm going to multiply it by the bottom, okay? So when I take the 20 and multiply it by the top, now I'm going to show all my work this first time, but as you do this more and more, you can show your steps less and less. So I'm going to show the 20 multiplied by the top. So there's the 20 multiplied by the top. And when I do that, the 20 and the 20 cancel out. And I just get 4a squared minus a minus 5. So when I multiplied by the top, all that happened is the 20 and the 20 canceled out. So 20 times the top, the 20s cancel, I'm just left with this. Then I'm going to go ahead and I'm going to do the 20 multiplied by each of the bottom pieces. So I'm going to say a over 5 times 20 minus 1 over 4 times 20. So you can see that I'm taking the 20 and I'm distributing it to each piece. So 20 divided by 5 is 4. So for the first piece, I get 4a. 1/4 of 20 is 5, minus 5. So I've got just this. Now we can do the factoring again, but we've already done the work for the factoring, so I'm just going to kind of copy down the factoring that I did. So we would do the same thing, we would factor, and here our factors end up being 4a minus 5 times a plus 1, so I'm just copying it down. Sorry, I'm off the screen a little bit, but I'm going to move it back up. So I did this factoring work. And then I cancel my common factors. And I get the answer is a plus 1. And you can see that overall, I showed this work, but once I don't have to show this work anymore, once I can start to do this work in my head a little bit, this method is way faster. It's a lot faster, it's a lot easier than doing all of that work. So this method is what we're going to do for the rest of the problems, and we get the same answer. Okay, so we're going to do 2 more examples using that method. Here is the next problem. All right, next example. We're going to have 1 over u minus 5 over 9 divided by 5u minus 9 over u squared. So what we need to do is we need to figure out what our least common denominator is, and we're going to multiply the top and the bottom by all of that. So we have a 9, we have a u, we have a u squared. So the least common denominator is kind of the idea of a common denominator, but instead of figuring out what each piece needs, you just multiply by all of it. So we need a u squared, the u and the u squared are kind of in common already, and we need a 9. So the least common denominator is 9u squared. So the nice thing about the least common denominator is you're not nitpicking to figure out what does each term need, you're just looking at the big picture perspective. So what we're going to do is we're going to multiply by 9u squared over 9u squared. Right? and then I'm going to multiply each term by that. All right, so on the top, I have 1 over u times 9u squared minus 5 over 9 times 9u squared. So if I have 1 over u times 9u squared, the divide by u is going to cancel out with times u squared. It's going to cancel out with one of these. So for the first term, I just get 9u minus. Now here we have a divide by 9 and a times 9, so the divide by 9 and the times 9 are going to cancel, but that's all that cancels, and then we have a 5 multiplied by a u squared. So 5 multiplied by a u squared. All right, so we've got that. And then on the bottom, we have a 5u minus 9 over u squared times a 9u squared. So here we're going to have a divide by u squared canceling with a times u squared. And then we just have to take this 9 and we can distribute the 9. So 9 times 5 is 45u minus 9 times 9 is 81. And at this point we are very close to finding our answer. Now, the top is in backwards order, so we need to reverse the top. So negative 5u squared plus 9u, 45u minus 81. And let's go ahead and factor so we can see if anything cancels. So on the top, we have to factor out a negative. We have a GCF of u, so I'm going to take a negative u out on the top, and that leaves me with 5u minus 9. On the bottom, we're almost undoing this multiplication that we did. We have a GCF of 9 and it leaves out the 5u minus 9. So we're basically undoing that multiplication we did, that distribution. So we can cancel the 5u minus 9 and our answer is negative u over 9. So eventually, once we get really good at this and we can kind of do this step in our heads, we would only have to show this work. But for right now, if you need to show this step, that is not a bad idea. That's a really good idea to show that step at this point. All right, one more example for the video, and then we'll save the rest of it to do class examples. So for this one, we're going to do 1 over 2 minus x minus 1 over 4 divided by x plus 1. So here we still have a complex fraction. It's two fractions in the numerator and then a whole number or an expression in the denominator. So whenever you see something like this, the very first thing you're going to do is you're going to take that denominator, you're going to put it over 1. You're going to turn it into a fraction, because we want everything in the problem to be in terms of fractions. So again, we're going to look for our least common denominator. Again, between 2 and 4, I'm just going to say that my common denominator there is 4. So we are going to multiply the entire problem by 4 over 4. And I'm going to distribute that to everything in the problem. So 1/2 times 4, that times 4, that times 4. So I've got 1/2 times 4, x minus 1 over 4 times 4, x plus 1 over 1 times 4. So for the first one, 1/2 times 4, we can say 2 divided by 2 is 1, 4 divided by 2 is 2. So we've got 1 times 2 is just 2. Here we've got the 4's cancel. And then we have to be very careful here not to kill, what is it, a baby fox? We have to distribute that negative. So the 4's canceled, we distribute the negative, we're being very careful. So 2 minus x plus 1. All right, then down here, the 4 doesn't have anything to cancel with, so I'm going to go ahead and just distribute the 4. 4x plus 4. All right. I can simplify what I have on the top. So on the top, I have a negative x plus 3. On the bottom, I have a 4x plus 4. On the top, I can factor out a negative, negative x minus 3. On the bottom, I can factor out a 4. You can see I distributed it, but I can factor it back out and just leave an x plus 1. There is nothing that can cancel there, and so this is just my answer. There you have it.